right, your homework last night was page 45 through 48 in your practice book. This was multiplying in scientific notation at the top of page 45. They've given you an example problem showing how to multiply numbers expressed in scientific notation. Now, their way looks a little bit different from my way, so you're welcome to do it my way or their way, but this is their work. Number 1 says, explain why the product of 10 to the 4th times 10 to the 7th in the example problem equals 10 to the 3rd and not 10 to the negative 28. The product rule says that you keep the base and you add the exponents. Keep the base and add the exponents. If you got 10 to the negative 28, then you would have been multiplying those exponents, and that would have been incorrect. Okay, this is multiplying identical bases. So we use the product rule, keep the base, add the exponents. Number 2 says, look at the example problem. Estimate the product of 5.3 times 5.3 times 10 to the negative 4 times 4.8 times 10 to the 7th and show your work. Is your solution close to the estimate? When they ask you to estimate, what they want you to do is they want you to round those constants so that you can do the math mentally. 5.3 would round to 5. 4.8 would round to 5. And then I would still have to combine my base 10s, 10 to the negative 4 times 10 to the 7. 5 times 5 would give me 25. And 10 to the 4th times 10 to the 7th would give me 10 to the 3rd. So here's my estimate, and here is the actual solution. I think they might have worded the problem just a little bit wrong. And the question is the estimate close to the actual solution? 25 times 10 to the 3rd, and that's not in proper scientific notation. Notice theirs is 10 to the 4th. We need to fix that. I'll move my decimal place. A decrease from 25 to 2.5 is an increase of exponents to 2.5 times 10 to the 4th. Now I can compare. Remember to compare. They need to be in the same form. Is 2.544 and 2.5 very close? Yes, they are. It's a reasonable estimate. Number 3, estimate the product of 0.47 times 9.2 times 10 to the 4th, and then find the product. Is your solution close to your estimate? Okay, if we was going to estimate, I could put this in scientific notation, which I'm going to have to do anyway. I could round. Be honest with you, rounding this is still going to be hard to multiply mentally because it's going to be 0.05 as a good estimate. And you still run the risk of messing up that decimal. So go ahead and put it in scientific notation. 4.7 times 10. We had to move the decimal place 2, and it is negative because it was less than 1. So when I estimate, I'm going to estimate using 5 times 9, which is 45. And then my base 10s, 10 to the negative 2 times 10 to the 4th gives me 10 squared. I need to move my decimal. I'm making it smaller or decreasing, so I increase my exponent to get 4.5 times 10 to the 3rd. They then wanted you to actually multiply. That's what they mean when they say find the product, to see if your estimate is close. Now, I do want to use my scientific form. I've got 4.7 times 10 to the negative 2 times 9.2 times 10 to the 4th. 4.7 times 9.2. 4.7 times 9.2 is 43.24. And then my base 10s gives me 10 squared. Still not in correct scientific notation. I'm going to decrease my constant and increase my exponent by 1 place value. giving me 4.324 times 10 to the third. Then they want to know, is our estimate close? Here's my estimate. Here's the actual solution. Yes, they are close. At the top of page 46, number 4 says, is the value of 1.7 times 10 to the fourth times 2.1 times 10 to the negative 8 greater than 1 or between 0 and 1, and explain your reasoning. If we was going to multiply this out, our base 10s, we would get a 10 to the negative 4 because we would add those. 1.7 times 2.1, even if it did go up to where we had to adjust the decimal, our exponent is still going to be negative, and if the exponent is going to remain negative, our answer is going to be between 0 and 1. Now, if you're not a fan of guessing, we could multiply that. 1.7 times 2.1 is 3.57. So, is this number greater than 1 or between 0 and 1? Because the exponent is negative, it is going to be between 0 and 1. Positive exponents are greater than 1, negative are not. Number 5, the thickness of a U.S. penny is 5.98 times 10 to the negative 2 inches. What is the height of a stack of pennies? So the thickness of one penny times, so 1 penny, that's going to be the thickness, times the number of pennies will give you the height of the stack, okay, the stack height. So the thickness is 5.98 times 10 to the negative 2. We're going to multiply that times 2.5 times 10 to the positive 4. Then we're going to multiply 5.98 times 2.5. Gives me 14.95. And then our base 10s, we keep the 10. We add negative 2 plus 4 to get positive 2. Now, because that's not in proper scientific notation, I'm going to decrease 14 to 1.4. Okay, if I decrease the constant, I increase the exponent. I decreased one place value, I increased one exponent, giving me an answer of 1.495 times 10 to the third. Now, if you're really curious about what that height would actually be, you would move your decimal, and you would have 1495 inches. That's a lot. It was a lot of pennies. Number 6. The speed of light is about 1.86 times 10 to the 5th miles per second. How many miles will light travel in 4,200,000 seconds? You are given a speed, which is a rate. You are given a amount of time in seconds, and they want to know a distance. This is your distance formula. Distance is equal to rate times time. The speed of light has a rate of 1.86 times 10 to the 5th, and it is going to travel for 4,200,000 seconds, which would be 4.2 times 10 to the 1, 2, 3, 4, 5, 6. And when we multiply those together, we will know the distance of how far the light has traveled. So we multiply our constants, 1.86 times 4.2, and we get 7.812. Then we're going to keep the base 10 and combine those exponents with addition. So 5 plus 6 makes 11. So the distance is 7.812 times 10 to the 11th miles. That's a lot, just so you know. Number 7, find the area of the rectangle in scientific notation. Now, area of a rectangle is length times width. The length and the width is given. One of them in scientific notation, one of them in standard form. I'm going to convert standard form, 2.75 times 10 to the 1, 2, 3, 4, 5. Now they're both in scientific notation and I can use my formula. The area is equal to the length, 5.4 times 10 to the 5th, times the width, 2.75 times 10 to the 5th. Now, the order of those two do not matter. You could switch them up. Just understand one measurement is the length, the other is the width. Now, 5.4 times 2.75 gives me 14.85. My base 10s will be 10 to the 5th times 10 to the 5th, which is going to be 10 to the 5 plus 5, which is 10. I am not in correct scientific notation, so I will shift my decimal, making 14.85 into 1.485. I made it smaller. I decreased by 1, so I will increase my exponent by 1, giving me 1.485 times 10 to the 11th. I will write that on my blank up here, and that's your answer. Number 8. A container at a paperclip factory holds 2.1 times 10 to the 3rd pounds of paper clips. There are 9.6 times 10 to the 5th paper clips in the container. Find the approximate weight of each paper clip in ounces. So we're going to have to calculate, and then we're going to have to do some conversions as well. So there's 9.6 times 10 to the 5th paper clips in the container. The container will hold 2.1 times 10 to the 3rd pounds. They're telling us how many pounds of paper clips the container will hold, and they are also telling us how many individual paper clips that is in the container. So if you take the pounds and you divide it by the number of paper clips, you're going to end up with, nope, that's upside down. We want to take the number of paper clips and we want to divide it by the number of pounds. That way that we will have a weight of the number of paper clips per 1 pound. Okay, we want to reduce this down and find out how many paper clips are in 1 pound. So let's start there. It holds 2.1 times 10 to the 3rd, and that's 9.6 times 10 to the 5th paper clips. You'll divide 9.6 by 2.1 to get 4, I'm going to have to round, 4.57. And then 10 to the 5th, I'll subtract the 3 using the quotient rule to get 10 squared. Now, that is this many paper clips per pound. So we're down to 1 pound. This is how many is in 1 pound. Now, they want to know how many paper clips are in 1 ounce. Now, if this is the paper clips in 1 pound, we want to divide the 1 pound amount by 16 ounces to give us the number of paper clips per ounce. Okay, this is a conversion. We're going from the number per pound to the number per ounce. So when I divide, my 1.6 is not in scientific notation, but the other number is. You could go either way here. I could take 457 and divide it by 16. Or I could make 16 become 1.6 times 10 to the 1. Either way is fine. I'm going to do 457 divided by 16, which gives me 28.56. In scientific notation, you would have ended up with 28.56 times 10 to the 0. Now, if they want that answer in scientific notation,